In this video, we'll learn about chemical nomenclature and focus on ionic compounds. So when we talk about nomenclature, what we're talking about is how we name compounds. This way we can convey the names of compounds easily back and forth without trying to say the formula out each time. So if we learn the rules of naming, you can examine a chemical's formula and determine its name, or you can look at a chemical's name and determine its formula. One thing to note is a lot of compounds have common names. So examples would be water is a common name. If we took water and looked at its proper systematic name, it would be called dihydrogen monoxide. And so if you want to impress or confuse or scare somebody, you can say, if dihydrogen monoxide is so safe, why did they remove it from space food? It's a great way to confuse your non-science friends. When we look at ionic compounds, it's a metal plus a nonmetal. So you can think of it's a cation and an anion. When you write our formulas, we always write it with the name of the cation and then the name of the anion. Most of the time, our cations are metals. Metals can be broken up into two categories. The ones that form one type of ion, so the ones that have a fixed charge, or the ones that form more than one type of ion, so they have a variable charge. First, looking at the fixed charge ones, because those are a little bit easier. Our fixed charged ones are usually our main group elements. So the main group ones tend to have a fixed charge. There's our one little metal. And then there are 4 transition metals that have a fixed charge. So that would be nickel, silver, cadmium, and zinc. Those 4 have fixed charges. And it would be good to remember these 4 in particular. Nickel, zinc, cadmium, all form +2, and silver forms a +1. The metals that have more than one charge are our transition metals. So looking at our transition metals, pretty much everything in the middle here, that would be where the variable charge ones are. And then the main group are the fixed ones. We'll circle those, say they're kind of unique transition metals. So you can think of it, the main group ones have a fixed charge, and the transition metals have a variable charge. So that means it can form more than one charge. Like chromium can form a +2, +3. Chromium can even form a +6 charge. Copper can form a +1 or +2 charge. Iron forms +2 or +3. Mercury is an interesting one. Mercury comes as mercury 1 ion. Actually comes as Hg2 +2. So that's kind of the equivalent of saying mercury 1. Or it just comes as Hg +2, which equals a mercury 2 ion. It's one thing to note with mercury, the Hg2 +2 is actually a mercury 1 ion. It just comes as a dimer. And so now when we look at naming these metals, if we look at the ones that form a fixed charge, so if it has a fixed charge, it's easy to name. You just write the name of the metal and ion at the end. That's it. So it's metal name, ion. So we have sodium ion, potassium ion, you can have calcium ion, barium ion. All of them are just ions. You can have silver ion. So if we look at silver, we just write, whoops, So if we look at silver, we would just write silver ion. If it has more than one charge, so it's one of our variable charges, typically our transition metals, then the charge is indicated in Roman numerals. So here I have iron 2 ion, or 2 is in Roman numerals. There's an older method of naming where you change the ending to OUS for the lower one, for the lower charge, and IC for the upper charge. But really the Roman numerals make your life so much easier. So you'd have iron 2 ion, iron 3 ion, and the 3 is written in Roman numerals in parentheses. Example, chromium 6, we write VI in parentheses for 6. It's about the extent of my Roman numeral knowledge is up to 9, 10. And then you always write the word ion at the end. So and there's one other thing. If our cation is a nonmetal, like say we have H3O+, that's what we call a hydronium ion. You add IUM to the end. Another example is if we have NH4+. That is an ammonium ion, which is different than NH3, which it forms from, is called ammonia. So you can see how you change the ending from IA to IUM. Now that we know how to name the cations, let's look at naming anions. Naming anions gets a little more complicated because there's a lot of different types of anions we have. For example, if we have a monoatomic anion, so if we have just an element, the ending gets changed to IDE. So chlorine becomes chloride, oxygen becomes oxide, sulfur becomes sulfide, nitrogen becomes nitride. I think that's kind of a more unique one. Nitrogen, N-3 becomes nitride. So if it's an element by itself, IDE. If it's a simple polyatomic ion, that ends in IDE as well. So if it has kind of just a -1 charge, if it's 2 atoms together, like OH- is hydroxide, CN- is cyanide. You can see they end in IDE. If your polyatomic ion contains a lot of oxygens, its ending can either be ATE or ITE. ATE is the one with the higher number of oxygens. ITE is the one with the lower number of oxygens. And the polyatomic ions become even more confusing. If you have more than one or more than 2 types, if you have more than 2 oxyanions, you add prefixes. So I'd add pre, oops. So I'd add per, that should be per, or hypo. So per goes with the one with the higher number of oxygens, hypo goes with the one with the lower number. So I use the chlorine ones as an example. And the ones that have more than 2 oxyanions typically are connected to a halogen. So your chlorines, your bromines, your iodines, they tend to have more than 1 oxygen state, or more than 2 oxygen states. So chlorine, if it's ClO4, that's the highest number of oxygens we can get on it. It has a -1 charge, becomes perchlorate. You can see the per and the ate go together. If it has 3, so I've taken away 1 oxygen, still -1 charge, now it's just chlorate. You can see we drop the prefix. Then if I take away another oxygen, still a -1 charge, ClO2, I change the ending from ATE to ITE to signify we have less oxygens. Then if you take away another oxygen, you have ClO, you add the prefix hypo. So hypo, with the prefix, goes with ITE. It also signifies the least number of oxygens possible. The per signifies the highest, and the hypo signifies the least. Now, if these rules are confusing for these, you can easily not worry about the rules and just memorize your polyatomic ions. And then finally, if you have hydrogen in it, you can have a prefix of either hydrogen or bi. What I mean by that is if we start with carbonate and I add one hydrogen to it, I get hydrogen carbonate or bicarbonate. Both of those names signify the exact same polyatomic ion, HCO3 minus. So that's another tricky one to watch out for. You can either call it hydrogen carbonate or bicarbonate, and they both mean the exact same thing. So with all these anions, you can kind of learn the rules, figure it out with the rules, or if it's one of the polyatomic ions, so it falls under numbers 2 through 5, you can look at the list on Canvas and kind of memorize that list. That'd probably be the easiest way to figure out polyatomic ions. So example of some of them you might have: hydronium, H3+, ammonium, and H4+. Those are our two positive ones. You can see those are the only two cations we have here. Those are only two cation polyatomic ions. Everything else, negative charge. So you have acetate, carbonate, hydrogen carbonate, chromate, dichromate, nitrate, nitrite, hydrogen phosphate, dihydrogen phosphate because we added two hydrogens. Or you can call it biphosphate instead of hydrogen phosphate. You have hydrogen sulfate or bisulfate. You have a sulfate. So all these different ones, like I said, I kind of recommend just almost making flashcards to memorize it. But these are some different polyatomic ions. So then once you know the names of the cation and the name of the anion, you put them together. You name the cation and then the anion. Now let's switch gears a little bit and talk about naming acids. When we name an acid, we're naming a compound that's usually an anion that has hydrogen in front of it. So we can tell it's an acid because hydrogen is written first and it's in an aqueous state. So for example, if we have a Cl minus and I turn into an acid, I get HCl. When we look at the endings, the ending will change so we can signify it's an acid. So instead of saying chloride ion, I now say hydrochloric acid. So you can see the ending of IDE switches to IC acid. And we do this for any monoatomic acid. So example, Cl minus, if I have HBr, that would go from a bromide to hydrobromic acid. We always add the hydro when it's the monoatomic one, so make sure you do that prefix. You can even do it for something like a sulfur. So we have H2S, as long as it's aqueous. That would give me hydrosulfuric acid. So you can see if it's an element by itself, add hydro, and then IC acid. Really not that bad. Now, when it's one of our polyatomic ions that becomes an acid, you have to look at the ending of that polyatomic ion and only the ending. One thing to note with our polyatomic ions, we don't change the prefix. So we don't add hydro anymore. Hydro is only for the monoatomic acids. So if it's polyatomic ion, I just change the ending. If it ends in ATE, the ending gets changed to IC acid. So perchlorate becomes perchloric acid. Or you can have sulfate. That becomes H2SO4 or sulfuric acid. Not to be confused with hydrosulfuric acid. They're very different ones here. Sulfuric acid, one of our strong acids, very reactive. Hydrosulfuric acid, not nearly as strong. And then finally, when the ending of that polyatomic ion is ITE, it gets changed to OUS acid. So example, if we have hypochlorite, becomes hypochlorous acid. Or we can have, if we stick with our sulfur, SO3 minus 2 is sulfurous. You can see, oops. Is sulfite. You can see that ITE. That becomes H2SO3 or sulfurous acid. Where we get the OUS and then acid. And finally, our last group that we're going to work on naming is binary compounds. Binary compounds are two nonmetals that are combined together in a neutral compound. So this is two nonmetals. Everything else you can see was a metal plus a nonmetal was our ionic compounds. Hydrogen plus an anion was our acids. Now we just have two metal. Now we just have two nonmetals. And when we look at our binary compounds, first, we want to name the element furthest to the left of the periodic table first. So you want to name this element first. And if they happen to be in the same group, you name the heavier one first. Then we're going to give the second element the ending of IDE. The first element keeps its name. The second element we change to IDE. Kind of like we're naming an anion, but these are not anions. And then we also add prefixes to tell us the number of elements. It's really not too bad. We have our prefix, just the name of that first element, prefix, name of the second element, ending in IDE. And so let's see what these prefixes are, and then we'll look at a couple examples. Looking at these prefixes, we can see when we're writing the formula, we want to include prefix to tell us how many of that particular element we have. So our prefixes are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. So if we remember these prefixes, if I have 7 of a particular element, I would write hepta and that element name. So you've seen these prefixes in other aspects of your life. But if you need to, I recommend memorizing them. It'll save us some trouble later. So when we're looking at naming, there are exceptions, lots and lots of exceptions. For example, if hydrogen is your first element, it doesn't get a prefix. None of the elements get a prefix. If you have just one of the first element, it doesn't get a prefix. So example for hydrogen, if I have H2S, and let's say it's a gas. So it's a little bit different than that acid we looked at. If it's in the gaseous state, you would write hydrogen sulfide, because remember the ending of the second element gets changed to IDE. If there's just one of the first element, it doesn't have a prefix. So you've seen this before in your everyday life. We have CO2. Everyone's seen this one, hopefully. It's written as carbon dioxide. You can see carbon doesn't get a prefix, but the oxygen does. Or even a more clear example, if we have CO, that would still be called carbon monoxide. So you can see we use mono for the second element, but the first element, even though it's just one, doesn't get a prefix. So when the prefix ends with a vowel, we drop one of the vowels. So the vowels you drop monoxide, instead of writing monoxide, because that looks a little weird, we drop one of the O's. And then for a tetroxide, instead of writing tetraoxide, we drop the A. But not if it's an I. It stays if it's an I. So di, tri, we leave them. So you have dioxide, that stays the same. You can also write trioxide. That stays the same as well. We leave the I. So if it's an O or an A, it gets dropped. If it's an I, it stays. And that just has to do with how it sounds when you say it out loud. Tetraoxide doesn't roll off the tongue as easily as tetroxide, or monoxide doesn't roll off the tongue as easily as monoxide. As I said, there's exceptions galore. This takes a little bit of practice, and then you'll get it down. So now you should be able to name ionic compounds, acids, and binary compounds. It'll be hard at first, but once you practice it, it'll be much easier and come to you more intuitively.